Okay, kids, time for homeschooling for today. So we're going to continue with the topic we've been talking about for the last few days, and that's who's the better basketball player, Michael Jordan or LeBron James? So our first question, how many championships has Michael Jordan won? Yes.
6.
Absolutely, you got it. And how about LeBron James? How many has he won? Yes.
3.
Yeah, just 3, that's right. So clearly Michael Jordan's better in that category. How about MVPs? How many MVPs has Michael Jordan won? Do you remember? Yes.
5.
5, that's right. Very good. Compared to LeBron? Yes.
4.
4, very good. So again, Michael Jordan's better in that category. Remember we talked about scoring titles. How many scoring titles has Michael Jordan won?
8.
8? 10. Okay, try to get that right. It's actually 10 scoring titles. And LeBron? Who knows? 2? Actually, he's only won 1 scoring title compared to Michael Jordan's 10.
Why do we have to know this?
Because this is part of your schooling, okay? Now that we're doing homeschooling, you have to listen to Dad's lessons. Okay? How about playoff points? Anyone have any idea? Yes.
Can we go play basketball now?
Well, we just... Oh, hey, class, I didn't hear you. You're listening in on our Michael Jordan, LeBron James lesson. Very good. We've got our own work to do, though, too, right now. Last lesson looked at the compound interest formula and compared that to simple interest. We're going to do some more work with the compound interest formula today and see the other things that we can do. So I think we're all finished up here. Let's get to it. We're going to start this lesson by revisiting the compound interest formula from last time. And in this example, we've got Harry, who has been lucky enough to have gotten some money, an inheritance. So in this case, if Harry is 13, then that money that he inherits would probably go into some type of savings account until his 18th birthday. And that's an example of where compound interest would come into play. So in this example, it's a GIC that pays 3.75%, compounded monthly. So we divide the interest rate by 12 to get our monthly interest rate. And then how many months between his 13th and his 18th birthday would be 5 years, and 5 times 12 is 60. So if you plug that into your calculator, then you will find out that he actually gets $9,164.67. Another time you might see compound interest is with a loan. Now, a loan is obviously not a savings. A loan is when you borrow money, but you could think of it as an investment from the bank's point of view. They give you some money, and they expect that money to collect interest, and it does, and in some cases quite a lot. One example I have here is a $2,000 credit card bill that isn't paid. Now, how does a credit card work? Let's just talk about that for a minute. So, imagine through the month of May, I make purchases on my credit card. What happens is I don't have to worry about actually paying for the item. So suppose, I don't know, on May 12th, I make a purchase at the grocery store for a couple $100 or whatever it might be. Every credit card has a billing cycle. Let's just assume, to make it simple, the billing cycle is the month of May. So at the end of May, the credit card company adds up all my purchases and they send me my bill, and maybe I have until, I don't know, June 15th or June 20th to pay it off. If when my bill is due I pay it off, that's great. The credit card didn't cost me anything. I might have even earned some points for air miles or grocery store points or whatever else it might be. Didn't cost me anything. However, if when my credit card bill is due, I don't pay it, then the money that I owe on my credit card collects interest, usually a pretty high interest rate. And one thing some people don't know, say my credit card bill was due on June 15th, and I wait 2 days to pay it, so I'm late paying my credit card bill. I'm not charged 2 days of interest. I'm actually charged interest for each item based on the day I bought it. So that $200 I spent at the grocery store on May 12th would actually be like over a month's worth of interest, even if I'm just a little bit late on paying my bill. So it's always a good idea to make sure you pay off your credit card bill. There's nothing wrong with having a credit card so long as you have the money to pay the credit card bill at the end of the month. And in fact, it's a good way to actually establish some personal credit. Everyone out there, every adult has a credit rating that basically is a score sort of saying how good they are at paying off their bills, and it allows you to not only access money to borrow, but also to borrow at a decent interest rate. So it is a good way to establish some good credit to show that you're someone that can borrow money and pay it off by having a credit card. There are some benefits to that. So we go back to this example. We can use the compound interest formula again. Now we're going to assume, to keep things simple, it's $2,000, 17.5% interest compounded daily, and it's I wait a whole year to pay off the bill. Some credit cards do have interest rates that hard. I have no idea about this Capital One. It's just a picture. Some credit cards go up to 30% or even more for interest. So always pay off your credit card. If you really needed to, you should borrow money some other way if you can't afford to pay your credit card bill. Oops. Okay, and if you plug that into your calculator, you should get $2,382.39 for the amount that I would owe. Let's see what else we can do with the compound interest formula. Suppose that in this case we have a situation where we actually want to find the principal. So Susan will start university in 2 years. She wants to have $4,000 in exactly 2 years to pay her tuition, and she knows that she can save money at 2.5% compounded monthly. The question is, how much does she need to have right now in order to have $4,000 in 2 years? So if we think about the compound interest formula, and this time we can actually plug in the final amount. The principal is what we're looking for. Of course, we know the interest rate. And we know n is 24, 2 years, 12 months in a year. Now, how do I solve that? Well, look I'm solving for p. I have p times something equals 4,000. So I actually want to divide both sides by this mess right here to solve for p, and I will get 4,000 divided by 1 plus 0.025 divided by 12 to the power of 24. Now you can do that on your calculator. One other thing I'd like to point out, though, is you could use negative exponents. This expression here is the exact same as 4,000 times 1 plus 0.25 divided by 12 to the power of negative 24. So instead of dividing by all this stuff, if you wanted to, you could just use the negative exponent. It means the exact same thing. It's up to you to decide how to do it, but however you do it, you should get $3,805.12. Now think about that question and make sure that that should make sense. Okay, you need to have $4,000 in 2 years, so not a big surprise. Our answer is going to be a little less than $4,000. So you can see that we were, about $195 short, which means she would make about $195 in interest. Now, in general, this formula can just be rearranged so that you could say that P, the principal, will always be the final amount divided by 1 plus I to the power of n, or you could use the negative exponent. So those formulas are exactly the same. And you could do the question either way, either by subbing into one of these two formulas or doing the very short rearrangement. Now, sometimes in an example like this, we don't always refer to it as the principal. We sometimes call it just the present value to basically say it might not be the amount she invested right now. It's just the amount that she needs to have in her savings account in order for it to turn into $4,000. So using the word present value sort of implies the value today, not necessarily the starting amount, and often PV is used in that case. So another formula might look like that. And then sometimes instead of using A, sometimes you'll see FV for future value. They all mean the same thing, and you'll get used to seeing those as we move on. Last example in this lesson is solving for an interest rate. So Jerry has a savings account paying interest compounded monthly. He has $5,000 in the account, and in 2 years, the new balance is $5,152.18. So if we imagine, again, the compound interest formula, or write it down, we can plug in what we know. We know the final amount. We know the starting amount, $5,000. We don't know the interest rate, so I'll leave I in. We do know the time. It was 2 years, but compounded monthly is to the power of 24. Okay, now there's a little bit of algebra here. It's a little bit more difficult. We need to solve for I. The first thing we're going to do is we're going to actually take both sides of the equation and we're going to divide them both by 5,000. And I'm not actually going to write down what I get here. I'm just going to say divided by 5,000. And 5,000 divided by 5,000 is 1, so I just get 1 plus I to the power of 24. Okay, what do I do next? Well, I need to kind of undo the exponent here. And I can do that. Imagine you had something like x squared equals 10. Then you would say that x is equal to the square root of 10, or plus or minus the square root of 10, assuming you care about the negative answer. I can do the same thing with the 24. I can take the 24th root instead of the square root. So I want to know what the 24th root of 5,152.18 divided by 5,000 is. Once I get that amount, I won't even worry about doing it. Yeah, that'll give me 1 plus I. So I will be equal to that amount subtract 1. Oh, sorry, subtract 1 equals I. All right, now how do I do that in my calculator? Well, you might be able to do the 24th root in your calculator. That's a possibility. However, might be easier for you to realize this. Remember that x to the power of 1 over 24 is equal to the 24th root of x. That's one of our exponent laws. So we could, instead of doing the 24th root, we could just say to the power of 1 over 24, which might be an easier calculation to do in a calculator. I'll show you how I do it on mine. So if I pull up my calculator and I start by doing the division, of course, 5,152.18 divided by 5,000. Okay, get that amount right there. And now I'm going to do the power of 1 over 24. So I hit my power button, bracket 1 divided by 24, close bracket. I get this number right here, and then I minus 1 from it. And I'm getting this very funny number for I, 0.001250. So it seems like a very funny interest rate, very small. But then keep in mind, in the compound interest formula, the I value is the interest rate per compounding period, pardon me. So that in this case, that's the monthly interest rate. Well, we probably want to know the yearly interest rate, so we can actually take that number, multiply it by 12, and then multiply it by 100 to turn it into a percent. If we do that, times 12, times 100, and you get very close to 1.5%, which is our answer here, 1.5%. Okay, that's it for the lesson, and good luck with today's homework questions. See you next time.